All right, well, let's look at another instance of free fall. This is in Baby Huey. Now, Baby Huey was this cartoon that was created in the 1950s by Paramount. It was sort of the precursor to that Donald Duck, that more famous duck, and he's sort of the grandfather of Donald Duck. Now, in this clip, which you can link to right here, you're going to watch from 2:45 where it'll start up to about 3:15, and then you can click out. So go ahead and click there, and you can watch the video. Now in the video, we see Baby Huey. He goes up, and then he comes back down again. So he goes up, and then he comes back down again. There are a couple of different things that I really like. Let's forget about this for now. We're not going to talk about air resistance and all that jazz. But there are a couple of things that I like about this video because it really gets some things right, and then it gets some things wrong again. So I want to talk about the things that it gets right, one thing that it gets right, and then one thing that it gets wrong. Well, the first thing that it gets right, and it's really exaggerated in the clip. Now, in real life, it isn't that exaggerated, but is at the top of a trajectory. When I have something that is going up, traveling upwards, and then coming back down to the same position, at the top of the trajectory, the velocity goes to 0. All right, so that's something that they get right in this clip, and I like it because it's really exaggerated, as I said, and you can really see the thing come to a stop at the very top. Now, one thing that often in movie clips is shown, in cartoons especially, but isn't really true, is that you see him as he goes up, that it takes a real long time for him to go up, but then when he gets up there and stops, he comes back down really quickly. All right, so that, I'm going to give a little bomb, all right, because that's not true. In fact, motion like this is symmetrical. That is the same amount of time to go up is the same amount of time to come down, assuming that you're covering the same distance. And that's because, you know, your acceleration is equal to negative 9.8 meters per second squared. And so your object is going to act the same. So if I throw an object up, say at v equal 10 meters per second, it's going to travel up and then come back down again. And when it gets to the bottom, it's going to also be at 10 meters per second. Although in this case, it's going to be negative because it'd be traveling downward. And then at the top, it's going to have 0 meters per second at the top. So again, one thing that they got right, and that is that the velocity at the top goes to 0. So the duck in this case does stop for just a moment. And one thing that they get wrong is that the motion on either side is going to be symmetrical. The same amount of time to go up and the same amount of time to come down.